this paper was rejected 3 times before we got it published. It was very hard to get this published, even though I think this is some of the strongest evidence we had. But these are small numbers. And Frank's smiling over there because he knows what it's like to get rejected. That's the most times I've ever had a paper. I've ever had to resubmit a paper. You know, I think it speaks to a little bit towards some of the issues with doing studies in this area. And for what it's worth, I just thought I'd mention that for what it's worth. Because there are people here who participated in this study, I know there's people wondering, what about the other things that you measured? And what about the whole population? And I didn't want to talk about it because it's not published yet. But I feel that I have a duty to do that because some of the people who live in the community are in this room today. So I'm going to summarize some of the unpublished findings that we have for the entire population. And I'll tell you right now, the bottom line is it's confusing. It's difficult to interpret, and that's why one of the reasons it hasn't been published yet. We found unexpected results. The results were counter to what we had hypothesized. So I'm going to go through that with you, and we'll conclude with that. So we studied 280 subjects, about half male, half female. The majority were European Americans. That pretty much reflects the ethnicity in this area, the race and ethnicity. The participation rate was 64%. The mean age was 41 plus or minus 21 years. We wanted to study children. Children are more, their general height is more likely to absorb RF in the wavelengths for the radio and TV transmitters that are present up there. Unfortunately, we had about 24% of the population were children between 8 and 17 years old, but we had virtually no one in the high RF exposure category. So it really pretty much obliterated our ability to look at RF effects in children. We just didn't have that many participants in the high exposure group. RF exposure, no matter how it was measured, was not associated with melatonin metabolite concentrations. There was no relationship. Cumulative 60 hertz exposures were associated with an increase, a statistically significant increase in nighttime 6-hydroxymelatonin sulfate concentrations. This is opposite to what we had hypothesized. It's important to understand. It was unexpected and in the opposite direction, and it was statistically significant, and was associated with 60 hertz exposures. Among those with elevated RF exposures, this relationship here was more significant among those with, among those with elevated RF exposures. So we wanted to look at the interaction between RF and ELF. So this effect here was really present in people with high RF and not among people with low RF. All right, so with regard to the immune markers, these are T-cell differential counts. It's fairly standard immune markers looking at all the different types of white blood cells. We saw that RF exposure was associated with an increase in total lymphocytes, total T-cell counts. There was an elevation both in T helper cells as well as cytotoxic. These are 2 different subsets of T cells. So it was an increase in T cell counts associated with RF exposure. Looking at people, looking at this effect, or looking at the relationship between melatonin and immune markers, I already showed you this data. There was an increase in immune markers with increasing melatonin production. So people who had higher melatonin production had higher immune cell counts. And so that was something that we expected, and that happened both in the postmenopausal women and also in the total population. And then the The associations between RF exposure and immune markers was observed among persons with low melatonin metabolite excretion, but not among those with elevated melatonin. So we did the same type of analysis where we broke up people into groups with high and low melatonin, and this effect of RF on immune markers, this increase, was really only observed in people with low melatonin production. So I hope I've thoroughly confused you, because we've been grappling with the interpretation of the data for some time now. And I think you can get a sense of, we're seeing increases where we expected to see decreases. We did not hypothesize this. It's a novel observation. Given the fact that my paper, the best data that we had trouble publishing that. And so we're still grappling on what to do with this. It needs to be published. It's an important story. The interpretation is difficult. And so I'll leave you with that. So let me just conclude. So there's a couple things I just want to point out. RF exposure is very common, and it's becoming more common. And so we need to deal with some of the issues. There's been a lot of data presented today, but really, when it boils down to it, there's no real conclusive evidence that RF causes a lot of different health outcomes, cancer or otherwise. It's still being hotly debated. Adequate exposure assessment is critical, and so I think one of the things that was really helpful out of this study that we did was to show that some of the various components of RF exposure, visibility, temporal factors, these are all important to document so that future studies can really take these things into consideration. The GAS model that we developed, for example, very helpful in being able to predict whether or not somebody's going to have high RF exposure. So if you can do this without having to go to that person's home, if you just know their latitude and longitude, then you can go back and reconstruct what their exposure has been over time, rather than trying to use an estimate based on a one-time measurement. Human biological responses are important, so that's why we wanted to study biomarkers. I think they're the avenue to understanding the biology of RF and getting a deeper understanding of what the interaction between electromagnetic fields and living systems really is. And I think there's enough evidence to suggest at least that melatonin and estrogen may be candidates for further evaluation. And just let me, I can't conclude without really thanking some of the people who participated. No one person can do this type of research alone, and so we had some really great help. Mike Yost is at the University of Washington, very well-known industrial hygienist and very well-versed in the biological effects of EMF. John Reif is my mentor, Maggie Clark, who has completed her master's degree on this study and has since completed her PhD. Others involved with the study. Support by NIEHS was pivotal. We had good lab support as well as support from the local community and the local regulatory folks. So that'll conclude my talk.